Okay, we're going to get started. Thanks for joining. This session is about OpenStack, Neutron, OVS, and the brave new world of SDN. So we're going to explain a bit about how all these things tie together. My name's T.R. Bosworth. I'm the product manager, one of the product managers for SUSE OpenStack Cloud. And Mark Darnell is also working as product manager with me on OpenStack. So let's get started. So primary goal for this is really all about walking out of here really knowing what you need to know about what an SDN is, whether you need an SDN or not, potentially how OpenStack integrates with an SDN, and also how Neutron and OVS by themselves aren't, OVS isn't really an SDN, and we'll explain that in detail. So really, we wanted to make this an educational session. So thanks to our marketing guys that allowed us to do this. It's not really a product promotion, but more of a trying to get some understanding across about how things work. The other thing is this is actually part 3 of our what we've done in the marketplace in the last 2 summits. So this is the third part of a 3-part series. So this is our agenda. We're going to kind of define what software-defined infrastructure is around compute, storage, network, and Open vSwitch. We're also going to talk about why or what an SDN is and why I would need one. The next thing is we're going to talk about Neutron, and I'll switch topics back to Mark when we start talking about Neutron. And the idea of this Yugo versus the Camry is a car analogy we'll use to say, hey, maybe the OVS and Neutron are your Yugo, and it's good enough for most of your use cases, but maybe an SDN is more like an upsell or a little bit nicer car to drive. Has a few more features. And then we'll talk about the luxury sedan. We'll actually talk about a particular use case of an SDN implementation. And then we'll also give you kind of a review of when you would use what technology for what use case. Wrong way. Okay, so this is our blueprint for software-defined infrastructure from SUSE. We have built this infrastructure based on our enterprise Linux capabilities. So the base enterprise quality Linux operating system is really the foundation for everything that we build upon. Part of that offering is providing a virtualization engine, KVM. We also have software-defined storage in a Ceph offering. And as well, we have all the components and networking that you need to build out SDNs to provide things for network function virtualization. Driving this is the OpenStack, our OpenStack distribution, which gives you all the APIs to programmatically define everything that you want to do in your software-defined infrastructure. At the very top here, we have a Kubernetes offering. Now, Kubernetes that we provide can run directly on bare metal, or obviously you can deploy it on OpenStack. So we've integrated that testing and feature function so that you can do either bare metal deployments or straight away on OpenStack. At the very top there, we have a Cloud Foundry offering. It's called Cloud Application Platform, and this allows you to develop very easy to develop microservices applications that are actually deployed on Kubernetes. So you can basically start at the top with application development, deploy it on Kubernetes, and also run it on a cloud. So this is what we're going to talk about, but this is just a kind of a background of our blueprint for software-defined infrastructure. So what I want to do is I want to just kind of set the stage of we're going to really focus in on network, but there's really three legs to the stool in virtualization and software-defined infrastructure. You have compute, storage, and network. So we'll briefly go through those now. So this is a physical data center before any kind of virtualization and infrastructure that we have currently now. So typically what you had is you had these switches at the top. You had various focus groups like mainframes, Unix, and then microsystems, and everybody had their own little domain that they took care of, and it was very hardware-centric, and you basically programmed the switches and did everything with a particular vendor and a particular set of storage. So you can see down here, you have typically 5 to 10 admins that were very specialized for each of the areas that they worked in. Oop, wrong way. So the very first area that we virtualized was the compute side of things. So we started out with things like VMware or KVM virtualization, and we started building out VMs. And so we kind of got rid of the specific hardware. So that was kind of the first step. And as we did that, we started to reduce our admin count. You can see that it goes down because you're just taking care of the virtualization compute layer and deploying virtual machines. The next step in the process was really building out this software-defined infrastructure for storage. And this typically, you can see that we have a similar set of switches at the top for the clients coming in, and we're starting to use a set of generic switches on the back end doing iSCSI storage instead of a particular vendor's proprietary storage that we had in the first stage of the migration. So the next thing that we have done is we've gone in and we're going to focus now on the network. So we did the first 2 legs of the stool, and now we're going to really focus in on networking. And so what we did is we replaced that physical switch with an open switch, a software switch, OpenV switch. And so it's handling the traffic that's going between the various VMs, and you still have the similar backend that we're going to talk about. So at this point, I'm going to turn it over to Mark, and he's going to drill into the actual Open vSwitch part of this configuration and setup.
Thanks, TR. All right. So once again, what we're doing here is we're zooming in on one compute node, and the reason why all those little machines are there is these basically show you what a compute instance is sitting on top of an OpenStack compute node. These need to talk to each other somehow. If you've got east-west traffic that's happening just within that one node, that Open vSwitch provides you with potentially faster than line rate communication across these devices or between these instances. So let's take a look at what Open vSwitch really is. First of all, it is a virtualized switch. There tends to be a lot of confusion that I've encountered in the industry whenever talking with customers about, hey, I use an Open vSwitch SDN. No, you don't. You use an Open vSwitch virtualized switch. SDN actually is a little bit more functionality, and we'll drill into that a little bit more momentarily. So like I said earlier, this allows you, an Open vSwitch allows you to link these instances together. It has a lot of really cool features. It's more than just plugging wires together. There are a lot of features like, VLAN, GRE, different tunneling capabilities, a lot of additional protocol functionality that if you go look at the openvswitch.org website, you'll find documentation on this. If you need pointers, please talk to TR or myself after the talk. We'll point you in the right direction. Historically, virtualized switches inside a Linux node were done via Linux Bridge. And Linux Bridge is an extremely capable technology, but it's much less capable. So over time, what's happened is Open vSwitch, whereas Linux Bridge was the default within OpenStack as we first built it, Open vSwitch has really taken over from Linux Bridge. Here's one of the really cool features. Has anyone used live migration inside OpenStack? Raise your hand. Okay. So when you do a live migration, what you've got is you've actually got 2 different compute nodes, and you've got an instance on one, and you need to spool that instance down. You need to move that instance across to another machine. And it needs to talk to the same systems that it was talking to before. VLANs are the mechanism we use to do that. So you've got a configuration inside this Open vSwitch that you've configured a port on this switch. You need to be able to migrate that functionality across just like you're migrating the instance. And Open vSwitch is literally built to be able to suck the configuration state out of the first switch, program it onto the port on the other switch on the other compute node, and then migrate the instance across. Transparent migration. So Open vSwitch enables you to do this kind of stuff. One more point of emphasis. Once again, it is not software-defined networking. OVS is a worker. It's not the big picture SDN policy controller that we'll be talking about momentarily.
So what's the car picture for?
All right, so the question, we had a little bit of a mic issue there. So TR asked the question, what's the car for? We want to really drive the analogy consistent with the car mechanism of Yugo, Camry, luxury sedan, and the different functionalities we're talking about here. When you think about a car, OVS is the engine inside the car. It does all the work of moving packets around. If you want something that actually controls what that engine is going to do, well, it's partially the driver, but in keeping with the car mentality, it's really the engine control unit, the computer inside the car that monitors and controls everything. That's the SDN piece. Let's go ahead and walk into what SDN is and why we end up needing this. So SDN, the definition of it has changed over time. I'm going to debunk a couple of historical definitions, and then we're going to go into what it really is. So the first definition that came out was separating the control plane from the data plane. That's part of SDN, but that's not SDN in of itself. And the reason why is, fundamentally, if you go down to a computer store, buy a switch that has the ability to plug several computers in and then a management port, those are separate control and data planes. But it's one switch. It's definitely not SDN. Okay, so let's rule out that one. And we don't use red a whole lot in our slides for obvious reasons, but when we come to, nope, that's wrong, that's when we use red. So on to the next one. People conflate OpenFlow together with SDN. And OpenFlow is a consistent way of programming switches, okay? The problem is that OpenFlow is not a flexible enough standard. So vendors tend to add to this because you need to add functionality. Therefore, OpenFlow is a good part of SDN, but it is not SDN in of itself. The best and current definition that we're working from is this verbatim, because this is really important. It's a very loaded definition. It is centralized policy creation, management, and deployment of that policy to multiple types of network devices via programmatic mechanism, okay? If you go Google SDN, you're going to find the prior definitions I gave you, and then this one will not show up quite as clearly, but I guarantee you, if you go talk to, say, Juniper is over here, an SDN vendor, Cisco's over there, another commercial SDN vendor, this is the definition they will most agree with. It includes a separate data and control plane, it enables OpenFlow compliance, and it allows you to add even more features that the OpenFlow spec does not give. All right, so TR, why don't you take why we would actually, or why SDN is really useful to people?
Okay, sure. So this is a typical network architecture that we've seen historically. You have a big switch at the top that's your aggregate. It connects to top of rack switches, and it does the routing down to the racks. So typically, that's how people started the interconnect. Then you come in and you actually deploy an application. Let's say it's a 2-node HR application. You end up with basically a VLAN to describe and connect these systems together. Then you go a step further, typically, is you bring in a web application that you want to access from outside. You have to set up a DMZ, so you have another set of networks. So you can see that this is just one application you're working with. Now you start deploying many, many applications, this gets to be very complex. So the idea is that you add a brain in here, an SDN controller that orchestrates this and takes care of setting up all the things properly. And so that's what is really important about the idea of an SDN controller. You're taking that smarts and you're putting it in a central location so that you can programmatically drive your data center. I'm going to turn it back over to you.
Sure. So a lot of those switches that TR just showed you, you'll have different administrators for different switches. If you have a switch fail and you have to reconfigure them, there's so much error-prone capability there, or it's prone to so many errors that you really want to make sure that's an automated approach. Okay, so SDN really provides that value. Now let's go ahead and look at Neutron momentarily. And I'm not going to go into massive detail on this. It's a bit of an eye chart. This is directly off of OpenStack.org. This is what gets deployed when you deploy on a single compute node inside OpenStack 3 virtual machines that make up, say, let's do a standard web architecture. So it's going to give you a web server for a web application, a firewall to protect the database server, and then the database server that's in a special zone that you're not exposing directly to the internet, okay? So these 3 green rectangles up here at the top are actually those 3 machines. Here's your web server, here's your firewall with 2 different networks on it, and then your database server is over here. This infrastructure you're looking at, all of the boxes other than those 3 green boxes, are the plumbing that Neutron deploys for you whenever you actually create these instances, create two networks, and say, link them together. So you've got a set of VNICs that get deployed. You've got some bridges for technical reasons that Linux Bridge still does some things that Open vSwitch doesn't do quite as well yet. You've got another bridge, which is your internal bridge that links all of these together, and you've got a bridge that links that bridge together with the physical NIC inside the box, and those are exposed via VLANs. This is what Neutron does for you. Any of you who have done much networking work have had to dig into this and really troubleshoot these, and it's been tough, okay? So Neutron absolutely is an SDN controller. It's a kind of a Camry level SDN controller in the sense that it deploys a lot of policy, does all the heavy lifting for you. However, it does fall down in a couple of areas. And here's where it falls down. Those physical switches that are sitting out there, that if you remember back from the slides, TR showed you, pushing policy to those physical switches, Neutron's not so good at that. You actually will see some historical Neutron physical switch integration if you go out and Google, but what you'll find is that's been not contributed to for the past 2 or 3 years, specifically because vendors have found and users have found it's tough to do this, and that's why commercial SDN has really come into play. So TR, you want to walk through an example of a commercial SDN controller for us?
Sure. So this is the luxury car. This example is Juniper Contrail. One thing to point out is the way OpenStack is set up, it's pluggable. So your operations, even though you're going to use this commercial SDN, the operator from an OpenStack perspective is still interacting with Neutron, its APIs, and its typical operation mode. You set up the Contrail system with its controller and fabric and its various interconnects, and what you do is you add a Juniper Neutron ML2 plugin into OpenStack. And that's the communication part that communicates from OpenStack to the Contrail controller. So part of the setup for the Contrail system is to set up your policies and all the things that you want to offer as far as networking within Juniper Contrail. So this Neutron plugin takes the calls that come in to OpenStack, routes them into the Contrail controller, and it basically is sending these various requests down to the physical switches and also to the virtual switches. So this tends to be more performant for particular hardwares, because a lot of times the various SDN vendors have their own switches and different hardware that they integrate with, so you get a bit more close interaction between the hardware, the fabric, and the actual Contrail system. So you might have more granular policy, security policies. This Contrail system could also be controlling other things in your network outside of OpenStack. So a lot of times we'll talk about reasons why people tend to use SDNs. We'll go through some of the decision matrix next. But this is the overall picture of the Neutron plugin talking to the Contrail system. The commands are sent to the SDN controller, and the controller is basically handling all the things that need to happen in the actual virtual router on the server, as well as the physical switches to make it so that you have the same effect of using Neutron and Open vSwitch on its own, but this is the plug-in mechanism that's provided in OpenStack. So what I want to close with is kind of a decision matrix. When would you use Neutron on its own with Open vSwitch? When might you consider using an SDN? When you might be forced to use an SDN? So we'll just go down the matrix here. Obviously, if you have a self-contained cloud and it's only OpenStack, and you really want to be master of your own domain, you don't want to have to talk to anyone outside your group, then obviously the self-contained Neutron-only implementation would be something that you would choose. Then the next one is kind of a choice where you may have a common network, but they kind of segment out part of the network and give you some fixed addresses to run OpenStack, and then the rest of the network they're doing other things with. So you have the choice of using Neutron only in that circumstance, or for a variety of reasons, you may use a commercial SDN. So that's one of the decision points. The third item here is interesting because sometimes the network team makes a decision and says, thou shalt use this SDN. And if you're the OpenStack person, you kind of need to interact with the SDN because that's what they require as a company-wide decision. And so in that particular decision matrix, then you're going to be stuck with a commercial SDN. But actually, it may be beneficial to you because we have this nice pluggable architecture in OpenStack so that you can plug these commercial SDNs and still operate your OpenStack cloud in a similar manner that you did before. Now, one of the big benefits is the hardware acceleration, scalability, and feature integration between the actual hardware, network hardware, and the commercial SDN. And so you can get a lot you can do pretty good with just using Neutron on its own, but as far as really using the available hardware acceleration and scalability that some of the SDNs provide, that's going to be really a better choice in this particular line. And then the last one is just politics. Anywhere you have people, you have politics, and there's going to be choices made where you just have to live with whatever the politics sorts out. So that is what we were really wanting to cover today. I hope this was useful. If you have questions, we can take them now. If you want to come over and visit us at our booth, we're right over here. We're a lot of fun. You can come talk to us after the session. Do you have any questions? Okay, thank you very much.
Thanks, everyone.